Joining us today is Peter Woodford, owner of LSM Technologies, who will be speaking at IIR's Collision Avoidance in Mining Conference, which takes place on the 8th to 9th of March 2011 in Brisbane. Hello Peter, thanks for joining us.
Hi, how are you, James?
What are the key issues in operator visibility on large mining and earth-moving vehicles?
The key issues are, operator blind spots around the machine and the equipment where visibility can be satisfied by conventional means, e.g. mirrors. The key issues are the size and obstructions on and around the machine that restrict or impair the operator's view to safely complete their task.
And what are the main causes of vehicle-to-person, vehicle-to-vehicle and vehicle-to-infrastructure interactions?
The most significant or primary causes for such incidents can be related to poor and impaired operator visibility around vehicles or machines and equipment. Blind spots are the key visibility problems, and they occur predominantly at low speeds, between 0 and 10 kilometres an hour, in situations where there is close proximity between vehicles and people, and primary rearward travel, and other blind spots around the peripheral of the machine.
Can you run me through the ISO 5006 standards for operator visibility and mandates for the 360 visibility blind spot elimination around vehicles?
Yeah, pretty easy. To quote directly from the actual ISO 5006 standards, the purpose of this international standard is to address operators' visibility in such a manner that the operator can see, and this is a key word, see, around the machine to enable proper, effective and safe operation that can be quantified in objective engineering terms. And again, the onus is on seeing, on the visibility aspect of it. It continues to say, the maskings due to the machine, its components and attachments are determined around the machine on a boundary line 1 metre away from the smallest rectangle that encompasses the machine and on the visibility test circle. And the radius of this circle is 12 metres, but it can be actually larger for bigger machines. Now the ISO 5006 goes on to say further that where the direct visibility is considered inadequate, additional devices for indirect visibility, such as mirrors and CCTV systems, can be used to achieve acceptable visibility. For the rectangular 1 metre boundary circle around the smallest footprint around the machine, additional devices for indirect visibility, mirrors and CCTV, are preferred. Other aids, such as underneath the ISO 16001, can be used in exceptional circumstances, such as hazard detection systems. Now, there is no other Australian or international standard that I'm aware of that mandates the use of other technologies such as proximity detection, radar, laser, GPS to mitigate vehicle-to-person, vehicle-to-vehicle infrastructure safety issues that are created by such interactions.
And how do ISO 16001 test procedures and criteria for the development of visual aids assist in detecting people and hazard detection systems for detecting objects?
Well, look, the standard defines the difference between what is a hazard detection device to actually detect objects, not for people, and a visual aid that is used to detect a person. For example, car manufacturers class the reversing sensors on the back of a vehicle as a hazard parking assist device and advocate strongly in their manuals that this is not to be used as a safety device because it's avoiding damage to the vehicle. However, conversely, they advocate rear viewing cameras as a safety device, like mirrors, as it provides visibility. The ISO 5006 standard also defines the minimum performance criteria for VA, visual aids, and hazard detection systems. So these devices have a better chance of reliability and functionality within their respective operating environments.
Is there a risk that the combined effect of all this technology can in fact hinder safety?
Oh, absolutely. Look, there is so much happening inside of an operator's cabin with warning buzzers, indicator lights, engine dispatch information, etc., etc. The more information and interaction demanded of the operator to not only interpret but also to respond to such technologies, the more distraction that can occur. Repetitive and false alarms, cabin noise levels, etc. can also quickly develop inadvertent complacency as well as a situation deafness. There is much to consider when selecting the appropriate technology for any equipment operation. One needs to carefully assess the equipment, its operating requirements and environment, etc., so as to ensure the risk is mitigated and not increased as a result of introducing other technology deemed to enhance safety.
Look forward to your presentation at IIR's Collision Avoidance in Mining Conference, which takes place on the 8th to 9th of March 2011 in Brisbane. Peter Woodford, many thanks for your time.
Thanks, James. I look forward to it as well.